Atomic symbols and isotopes. This is the typical information that you see on a periodic table. And you'll have the symbol of the element. You may or may not have the name of the element. And then there's usually two other pieces of information there. They're not always at the same place. You will have the atomic number, and you will have the atomic weight. And so we're going to say a couple things about how this relates to what's in the atom. Number one, we're thinking about our atom with our protons and neutrons in a nucleus. Our electrons are in this electron cloud. And in chemical reactions, it is the electrons that can be gained, lost, or shared between atoms. We also have nuclear reactions, which we really cannot control easily, but they involve changes within the nucleus. So most of the things, when we talk about chemistry, we're talking about the electrons being involved, not the nucleus and the protons and neutrons. But we do need to talk about what's in the center of the atom and how atoms, even if they're the same element, may be a little bit different. First, we have the atomic number, which is the number of protons in the nucleus. This is the number that you will see on all the periodic charts. It will start with 1 for hydrogen and go up through 92 for uranium and possibly further for some of the other synthetic elements. It is the fingerprint of the atom. So it also represents, because it represents the number of protons, it always, if you know the atomic number, you know the element. If you have 1 proton, you have hydrogen. If you have 6 protons, you have carbon. No question. Always true. We have a mass number, and you will not see that on the periodic table. The mass number is the number of protons plus the number of neutrons in the nucleus. And together these are called nucleons because they all are in the nucleus. But the number of neutrons is where one atom can differ from another. And this is where we get the possibility of having isotopes. So let's just take a look at hydrogen. When we think about hydrogen, we can think there are actually 3 isotopes to hydrogen. And each of those isotopes has 1 proton. But we can have 0, 1, or 2 neutrons. And because the mass number is the protons plus the neutrons, we can have a mass number of 1, 2, and 3. And the way we will write to tell you what particular isotope it is, we will take the symbol, for example, hydrogen, and we will put the mass number on the top left and the atomic number on the bottom left. So for our first isotope of hydrogen, it would be 1, 1. We've got 1 proton, and we have 1 proton and no neutron. For our second isotope, it would be 1, 2. We have 1 proton, and then 1 plus 1 gives us the 2 and for our last isotope would be 3, 1 hydrogen. We have 1 proton, and then the 1 plus 2 is equal to 3 for the mass number. And actually these two, well, all of the isotopes of hydrogen, any of the other isotopes. For example, carbon has 6 protons, and normally it has 6 neutrons, but it can have 8 neutrons. So we can have this isotope or this isotope. Now let me say one thing about the other number that is found on the periodic table. This is the atomic weight, and it is typically a weighted average of isotopes and it's the mass in grams of a whole mole of those atoms.
What are they doing?
Shh.